One afternoon and $150 of simple hardware store parts is all it takes to generate your own free electricity. By the end of this build, we'll put this unit side by side on a meter against a $5,000 commercial model to see the real numbers. Most of us are paying around $140 every single month for electricity. Over 10 years, that adds up to $17,000. That is 17 grand for energy you never owned, never stored, and never controlled. And you're paying for a grid that is shilling its age. Major outages have jumped 64% over the last decade. During severe winter weather in Texas, millions of people found out exactly what happens when that aging infrastructure finally gives out. Every single component needed to secure your power supply is currently sitting in the PVC and plumbing aisles at your local Home Depot. WIMP has always been free. We just need a way to start using it. Here is exactly what you need. 8 basic parts, including PVC pipe, a 24-volt treadmill motor, and a charge controller, totaling about $140. Add in 5 Conan hand tools, like a drill and a jigsaw, and you are ready to build. No welding, no specialized skills. Harnessing wind with these basic components provides a path towards self-reliance that bypasses expensive proprietary engineering. Step 1 is building the blades. Take your 5-foot PVC pipe and cut it into 3 equal sections, each about 20 inches long. Then, draw a diagonal line from one edge to the other and cut along that line to create a tapered shape that's wider at the base. Look at this cross-section. The curved PVC mimics an airplane wing. Airflow creates lift, pulling the blade to spin the motor. To catch more air, heat and bend the trailing edge down 15 degrees. This pitch adjustment increases torque for light freezes. Once bent, sand every single edge completely smooth. Rough edges create invisible turbulence, and that turbulence steals wattage before it ever reaches your battery. Spending 10 extra minutes on this sanding step is the cheapest way to maximize your output. You're guaranteeing those blades slip cleanly through the air. Now we reach the step that kills more DIY projects than any other: balancing. Hold the blade by the bolt holes between 2 fingers. If one end drops, sand that heavy end down until it sits perfectly level. Next, take your hub plate and use a protractor to space your 3 balanced blades exactly 120 degrees apart. Bolt them down tight. If you skip this, an unbalanced rotor will spin with a slight wobble. That wobble creates microscopic vibrations that will completely shatter the internal bearings of your motor in a matter of months. Perfect mechanical balance is what separates a weekend experiment from a reliable power generator that will actually run for years. Bolt the fully balanced hub plate assembly directly onto the shaft of your 24-volt treadmill motor. Hand tighten it first, then lock it down with a wrench. For the tail fin, cut an 8 by 12-inch rectangle out of your aluminum sheet. Drill holes at the base and bolt it straight to the back of the motor housing. That single piece of metal has one job: reading the wind direction. It uses basic fluid dynamics to passively swing the entire turbine, ensuring your blades are constantly facing directly into changing air currents. There are no sensors to wire and no tracking software to crash. Relying purely on physical design is simpler, infinitely more reliable, and keeps your turbine tracking the wind effortlessly. Wiring the system is straightforward. 2 leads, positive and negative, come out of the motor. Connect goes directly into the input terminals on your 12-volt PWM charge controller. Then wire the output terminals of that charge controller directly to your 12-volt battery. Make sure you use marine-grade wire and seal every connection with heat shrink tubing so the whole system is completely weatherproof. Here is where people make a massive mistake. If you wire the turbine directly to the battery on a highly windy day, it keeps pushing voltage long after the battery is full. The battery overheats, and the internal liquid literally boils away. Skipping a $22 charge controller turns a $100 storage battery into a backyard fire hazard. The controller is what automatically stops that dangerous overcharging. Using inexpensive intermediary electronics like this is exactly how you safely manage and protect your off-grid storage system. To mount the unit, secure the turbine to the top of a steel pipe. Then, anchor the pole vertically by running 2 guy wires into the ground at 45-degree angles. Now we have to talk about wind quality. Wind close to the ground is broken up by fences, trees, and buildings. That low-altitude air is turbulent and slow. You can see the difference height makes. At 10 feet, the turbine struggles in chaotic, swirling air. By raising that exact same unit to 20 feet, it accesses fast, straight, clean air currents. Doing this can literally double your power output. You don't always need a bigger motor or longer blades. Elevating your hardware is the most cost-effective way to multiply your total energy extraction. So, what does this actually produce? In a light 10-mile-per-hour breeze, you'll generate a continuous 10 to 20 watts, perfect for trickle-charging batteries overnight. When the wind hits 15 to 20 miles per hour, that scales up to 100 watts, which is plenty to run LED lights or a small fan. This data table directly compares our build against a $5,000 commercial unit. In a 14-mile-per-hour wind, the commercial turbine produces about 90 watts. Under the exact same conditions, our $150 bill sits right behind it at 75 watts. The commercial unit certainly wins on peak output, but look at the math. For the cost of just one off-the-shelf system, you could build an entire array of 33 DIY turbines. And when mechanical parts eventually wear out, you aren't stuck calling a manufacturer and waiting weeks for a proprietary warranty replacement. You just unbolt the $35 treadmill motor and swap in a new one immediately. I've linked the exact parts and tools you need in the pinned comments below. Next time, I'm going to wire this exact turbine into a $200 solar array to build a hybrid system, so when the sun goes down, the wind takes over. True energy independence comes from the total repairability of your own systems. When you build it yourself, you own the power and the knowledge to keep it running forever.